everyone, so now we're going to be talking about how to add and subtract rational functions. In the last video we talked about how to simplify them. Now we're going to learn how to actually use them a little bit. So when we add and subtract rational functions, because these rational functions are fractions, the biggest thing that we need to do is make sure that the denominators are the same. In order to add and subtract fractions, as you might remember, the denominators, you need to have common denominators, or they need to be the same. And so the first step and the biggest step is to make sure that you have common denominators. Once you have common denominators, then you can just add the tops. So let's start with this first example. We have x plus y over 10x cubed plus 3x minus 2y over 10x cubed. So notice that the denominators are the same. They're both 10x cubes, which means that we can add these together. And so when I add them together, I can actually write it out kind of like x plus y plus 3x minus 2y all over 10, the common denominator, which is 10x cubed. All right, and then we're just going to combine like terms on the top. So my like terms are the x and the 3x, and even though they're in separate sets of parentheses, because there's a plus in between, we don't need to change any of the signs or anything, we just combine them. So x plus 3x gives me 4x, and then we're going to combine the y, so y minus 2y, that's like a 1y minus a 2y, which would give me a negative 1y, or we can just say negative y over 10x cubed. Now, potentially we could simplify this if it was possible, but I'm going to tell you on this one it's not possible. The reason why it's not possible is because even though I could probably simplify the 4x and the 10x cubed because they both have x's, they're both divisible by 2, because you have that extra y attached, that minus y, you need to, if you remember from that last video, everything needs to be simplified. So you can't just simplify the front chunk and the bottom chunk, you have to be able to simplify the entire thing. Because you can't do that, because that y doesn't have anything in common with the 4x or the 10x cubed, you're done. This is your final answer and the simplest answer. Okay, so now let's look at another one. On this one, we have 3x over x squared plus x minus 6 minus 4 minus x over x squared plus x minus 6. Once again, we have those common denominators, but notice that these are a quadratic trinomial, the ones that we can use the box method with. So before I start anything, I'm just going to try and I'm going to factor the bottom first, just in case something simplifies out or before I actually add or subtract. So let's draw the box. Then we put the x squared on the top, minus 6 on the bottom. We want to find two numbers that multiply to be negative 6 and add to be 1. So we know that 6 times 1 is 6, and we know 3 times 2 is 6. In order to add to be 1, I think we're going to have to use the 3 times 2, where it's a positive 3 and a negative 2, because 3 times negative 2 would give me negative 6, and 3 minus 2, or 3 plus a negative 2, would give me 1. So I'm going to put a 3x in one of the boxes, a negative 2x in another box, and let's figure out what they have in common. So the bottom two boxes have a negative 2 in common. I can divide both of those by negative 2. The top two boxes have an x in common, the left two boxes have an x in common, and the right two boxes have a 3 in common. Notice I don't take a negative out of that one, even though the 6 is negative, because that number with the x, the number I put in last, isn't negative, I can only pull a positive number out. So my factors are x plus 3, x minus 2, which means I can rewrite this as 3x over x plus 3, x minus 2 minus x minus 4 over x plus 3, x minus 2. Okay, so unfortunately it does help. It was great because now we know what the factors are, but it doesn't help us simplify beforehand. Because there's nothing in common. Like if I just looked at that first fraction, I couldn't cancel out the 3x and the x plus 3. That's not the same, even though they have the same number and letter, because one's 3 times x and the other is x plus 3, doesn't work. Same thing on the second fraction. There's nothing that they have in common, so I can't cancel anything out. But what I can do now is, because they have common denominators, I can just add the tops, or in this case, subtract the tops. So I'm going to have 3x minus x minus 4 over x plus 3, x minus 2. And then this negative that's on the top distributes itself, so it'll change the signs inside the parentheses. So I'd end up with 3x minus x plus 4 over x plus 3 x minus 2. All right, now we can combine like terms, and the like terms are the 3x and the minus x, which would give me 2x plus 4, because 3x minus x is 2x, x plus 3x minus 2. And then, okay, so potentially we could be done here. I'm going to show you how to simplify a little bit more. The top, those two top numbers have a 2 in common, excuse me, which means I can take a 2 out of the top. So I can rewrite that as 2, and then in parentheses x plus 2, because I'm just dividing the 2x by 2, which gives me x, and then the 4 by 2, which gives me 2, over x plus 3 x minus 2. Now, potentially, like, if you could cancel anything out, this would be where you would do it, but you can't cancel anything out. Even though you have an x plus 2 on the top, x minus 2 on the bottom, because they're different signs, you can't cancel those out. So this is my final answer. It's a pretty factored form final answer, but there's nothing that can be canceled out. Okay, let's look at this third example. On the third example, instead of using factors like the box method, we're going to, this looks more like monomials, or things with just multiplying variables and coefficients. So the first thing I'm going to do is simplify the fractions. And the way that I'm going to do that, if you look at that first fraction, both the top and the bottom have 1v, which means I can cancel that v out. So I can rewrite this first fraction as 2 over 5u squared. Okay, and that just helps because now I don't have to deal with that v. Then the next one, for the second fraction, I have 6 over 6u cubed. If you notice, they both have 6's on the top and the bottom, so I'm going to cancel out those 6's, which just gives me 1, because remember, when I canceled the top out completely, I use a 1 over u cubed. Now, that helps because they're a little bit smaller, but unfortunately, we don't have common denominators, which means that now we need to get common denominators. When you don't have common denominators and you want common denominators, what you have to do is figure out what you have to multiply each of them to get them to be common denominators. So I know that this guy needs a 5, right? Because the left side had a 5. But now if I multiply the right side by 5, I would end up with 5u cubed. And the left side is 5u squared. So this side needs to be multiplied by u, so that it's 5u cubed. And if I can do that, then both of the denominators will be 5u cubed, which means that I can add. But in order to multiply I don't want to just multiply the bottoms. I have to multiply the bottoms and the tops, because what I do to the bottom, I have to do to the top. Just like when I'm canceling stuff out, what I cancel out from the top, I have to cancel out from the bottom. What I multiply to the bottom, I have to multiply to the top, which means that what I'm going to do, and I'm going to use a different color just so you can see this, I'm going to multiply this fraction by 5 over 5, because again, what I do to the bottom, I have to do to the top. And then I'm going to multiply this fraction by u over u. Okay, so when I do that, let's just start with the top, or the left fraction. I have u times 2 on the top, which just gives me 2u. And then on the bottom, I'd have 5u squared times u, which gives me that 5u cubed, which is what I was looking for. Then I'm going to minus. And on the right fraction, we multiply 1 times 5, which just gives me 5. And then on the bottom, we have u cubed times 5, which gives me that 5u cubed. And look at that. Now we have those common denominators. We had to multiply both the top and the bottom, but it did work. And so now that I have common denominators, I can write it out like this. 2u minus 5, because that's the two tops subtracted, and it's subtracted because of this minus sign, over 5u cubed. And this is my final answer. There's nothing I can simplify, even though the right top and the bottom have a 5 in common. Because that 2u doesn't have a 5 in common, we can't cancel it out. And so this is my final answer. All right, let's go through one more example. On this example, we have 2 plus x minus 4 over 5x squared minus 30x plus 35. So the first thing to notice is that the 2 is a whole number. It's not a fraction, but we can make it a fraction. And when you make whole numbers fractions, all you're doing is putting them over 1. So now we have 2 fractions, but they don't have common denominators again, right? which means that we need to have them to have common denominators. Notice that the one on the right-hand side, the denominator on the right-hand side, is a quadratic trinomial. So let's simplify that first, and then we'll deal with the common denominator. So the first thing I notice on the bottom of this, I'm just going to deal with this thing first, is that they all have a 5 in common. So I'm going to take a 5 out, which would give me x squared minus 6x plus 7. Okay, then I'm going to use the box method for the chunks that are in the parentheses, which means I have x squared up here, a 7 down here. I want to find two numbers that multiply to be 7 and add to be negative 6. Well, there's only one thing that multiplies to be 7, 7 times 1. And in order for it to add to be negative 6, that 7 needs to be negative. So negative 7 times 1 is negative 7. Negative 7 plus 1 is negative 6. So I'm going to put a negative 7 and then a 1 in the boxes. What do the bottom two boxes have in common? A 1. What do the top two boxes have in common? An x. The left two boxes have an x in common, and the right two boxes have a negative 7 in common. Okay, which means I can rewrite this as 5, because remember we took that 5 out right there, times x plus 1, x minus 7. Okay, so it doesn't help us simplify anything, but it just makes it look a little bit prettier. I'm going to rewrite the entire thing. We have 2 over 1 plus x minus 4 over 5 times x plus 1, x minus 7. All right, so once again, we're going to have to deal with this common denominator situation. You need them to both have common denominators, which means that really all I'm going to do is multiply the left fraction by the denominator on the right fraction. The reason why I only have to do that is because the left fraction has a denominator of 1, and 1 times anything is itself, so it doesn't change anything if I multiply by 1. So I'm going to multiply, I kind of gave myself not a lot of room. I'm going to multiply the top and the bottom by 5x plus 1, x minus 7. But remember, I have to do it to the top and the bottom, because what I do to the bottom, I have to do to the top, and I need to do this to the bottom to get them to have common denominators. Okay, so if I do that, I'm going to have 5 times x plus 1 times x minus 7 times 2. And I'm just going to do the 2 times the 5, which would give me 10. So I'd have 10 x plus 1 x minus 7 over 5 x plus 1 x minus 7 plus x minus 4 over 5 times x plus 1 x minus 7. All right, now they have common denominators, which means I can put them all in one fraction. So now I'm going to have 10x plus 1 x minus 7 plus x minus 4 over 5 x plus 1 x minus 7. All right, now we're going to simplify this. And you might hate me a little bit, because now what we're going to do is take the top part, the 10 times x plus 1 times x minus 7, and FOIL that out, or multiply that out, just so we can combine like terms with the x minus 4. So when I have x minus 1 and x plus 7, if I multiply these two chunks together, I can show this to you, but really what's going to happen is it's going to turn into this guy right here, this x squared minus 6x plus 7, because that's what it factored out to be. So I can write this out as 10 times x squared minus 6x plus 7 plus x minus 4 over 5x plus 1 x minus 7. Then I'm going to distribute the 10 inside of these inside the parentheses. So I'd end up with 10x squared minus 60x plus 70 plus x minus 4 over 5 times x plus 1 x minus 7. Now I'm going to combine the like terms on the top. So 10x squared doesn't have a like term. I'm going to leave it as 10x squared. And then I'm going to end up with negative 59x, because I have a negative 60x but plus 1x, which gives me negative 59. And then plus 66, because 70 minus 4 is 66. And that's all over 5 times x plus 1 x minus 7. Now I'm going to tell you, this is my final answer. The reason why I know this is So potentially what you could do, or what you could try to do, is factor the top using the box method again, but I'm going to tell you that does not factor. Those are some really nasty numbers. I'm not going to expect you to do that. But so because it doesn't factor, then that's it. I'm done. That's as far as I can go. If it could factor, you would factor, and then if you have a factor on top and on bottom that are the same, those would cancel out. But in this case, it doesn't, and so you don't have to deal with it. And this is how we add and subtract rational functions.